Hey everybody, Matt from Eastwood. We're here in the Eastwood garage giving you guys a live tech session. So first I want to thank you guys that are watching that purchased an Eastwood TIG welder recently. This is an exclusive live crash course on TIG welding for you guys that purchased a welder recently. We have Scott over here on the chat doing the chat and answer questions.
Yep, so if you guys have any questions throughout, throw them down in the chat. I'll answer them live there. I can also throw them over to Matt. A little tip, if you're using which machine you're using, make sure when you have a question, throw that machine in there. It'll help us be able to answer you that much better so we know which one to reference the settings. So let's go ahead and get some welding done.
All right, thanks Scott. So what we're going to be working on mainly today, because it's probably the most popular machine that we sell as far as TIG welders go, is our TIG 200 AC/DC analog machine that's down here. That machine can weld basically most any material, but it is an analog machine that has just basic settings on it or basic knobs. It makes it really easy once you learn the knobs and the functions to jump right in and get TIG welding. So first thing I'm going to talk about is just safety, and then we'll jump into what the knobs on the front of the welder do. So for safety, TIG welding, you're going to use a lot of the same safety things as you would when you're doing MIG, arc welding, all of that. The only difference is that you may want to use gloves that are a little thinner. So if you have big heavy stick or arc welding gloves or even heavy MIG gloves, you may want to invest in a set of thinner gloves. So I have a set of Tillmans here that are our TIG gloves that we offer on the site. These gloves are going to be a little bit thinner, so your dexterity is going to be a lot better when you're actually trying to manipulate the torch and also feed your filler rod. So that's a quick little tip for safety. Helmet, you definitely want an auto dim helmet. When you're TIG welding, one of the biggest things when learning is getting comfortable and making sure that you can see the puddle. With an auto dimmed helmet, you're going to be able to see where your hands are at, where your workpiece is at, and you can get all set up so that you're not starting blind. So most times I say, especially for hobbyists that are learning, get an auto dim helmet. I'm using our XL True Color helmet, which is really nice. The True Color helmets have more of a blue tone to the lens, and it's a lot easier to see the puddle, which also is helpful when you're welding. So when I'm TIG welding, I usually set the amperage based on, or set the darkness of the lens on, depending on what I'm welding and the amperage I'm welding at. So I do a lot of sheet metal welding in my day-to-day, so I usually have mine turned down in the 9 to 10 range of the shade. But when you're doing heavier stuff, like 1/8 inch and up, you may want to turn it to 11, 12, or 13, depending on how high of an amperage it is. If you're unsure, it's always safe to run around that 11 range, and you'll be fairly safe doing most anything that the TIG 200 can handle. I'm also wearing a long sleeve jacket here, a welding jacket. With TIG welding, there's not really any type of sparks, but you do have the arc to worry about, the flash. From the arc, you can obviously hurt your eyes, which we've covered with the helmet, but you can get some basically sunburn on your arms or surrounding areas if you're not wearing a jacket. So definitely wear at least a long sleeve shirt, button up, or a welding jacket. Any of those are going to work just fine. So that is the basics for just your general safety equipment that you're going to need. Any questions before I move, Scott?
Yeah, we got one question so far about
sure.
wearing a respirator while you're welding. It certainly is recommended. Make sure you pick one up that's rated for welding, because the fumes are coming off aren't really that good to breathe in. You know, you may see a lot of guys who aren't wearing it. Matt's not wearing one right now. It's kind of hard to talk and have one on, but definitely recommend it. I always wear one. I know you do a lot when you're at home, and we certainly sell them, so hop over to the website if you need one.
Yeah, so if you're just doing some quick little welding, it's not always a big deal, but if you're definitely doing a lot of welding, where you're welding up a whole chassis or something, or you're doing a long stretches of welding, it's definitely good to wear that because there are fumes that come off of the metal. Even if it's perfectly clean, you may get some fumes that come off. So it's a good practice to wear some sort of protection when you are welding. So good question. So the front of the machine here, we'll show you some of the controls down here on our TIG 200. Before we even turn the machine on, I'll show you the basic controls. Whether you have the TIG digital or the TIG 200 analog, the settings are very similar, the main functions. So we'll show you guys those. So the first thing we have here is our power. That is our amperage that you're welding at. Now on the TIG 200 analog machine, there is a panel control and there is a foot pedal control. We'll show you the foot pedal in a moment, but if you're welding with the finger switch, you will control the amperage right here. So this is basically your heat and obviously the higher you go, the hotter it's going to get. The machine does weld up to 200 amps, so you can run it all the way up if you're welding thicker stuff, but a lot of general fabrication, you're going to stick anywhere from the 100 to 140 range for a lot of the meat of what you're going to be welding for automotive repair and things like that. You're going to probably be in that range, but you definitely can go higher. So that's your power. Over here we have our clearance effect. This is for AC side only. This is basically where we're going to balance our AC balance, where we're going to be balancing our cleaning effect versus our penetration. So we're just doing a crash course on the functions of this today, so we're not going to get too much into aluminum. If you have some specific questions, definitely drop them in, but that is just for aluminum. When you're welding steel, that function is not used. Down below we have our pre and our post flow. So these are rated in seconds. So on the pre-flow, you will notice that it's a fractional second. So I usually keep it around 0.2 to 0.4 in there. Basically what that's going to do is give you a burst of gas before the arc actually initiates. It's going to clean out and purge the line, and it's also going to put a little plume of gas out before you actually start welding, so that you don't have that split second of no shielding gas. So it's good to have that in there. If you're doing something more susceptible to having issues with contaminants like aluminum, stainless, you may want to crank it up even a little bit higher. But for general purpose welding, when you're beginning, you can keep it around 0.2 to 0.4 seconds. The post flow is going to be the same idea, just at the end. It's going to put gas out at the end, where you want to hold your torch over the puddle, and the amount of gas that comes out is controlled by this, or the length of time. So when you're doing general like steel work, you're going to probably keep it in the 3 to 4 range. Some guys that are trying to save gas will keep it even a little lower. But if you keep it in the 3 to 4 range, you're pretty safe. If you're doing aluminum or stainless, you may crank it up to anywhere from 5, 7 on up, depending on what you're doing. But if you're just learning on some steel, trying to jump in, you definitely could save some gas by keeping it in the 3 to 4 range, and it's still going to be safe, that you're not going to have issues with contamination. The other thing we have here is the foot pedal and panel control. So the foot pedal, as it sounds, we'll go with the foot pedal that is over here. I'll show that for Joe. So this is your foot pedal that comes with the machine. I also have on the table the upgraded pedal that comes stock with the TIG 200 digital, but this is the one that comes with the analog machine. You will notice that it has an amperage control here, so if you have this turned on at the foot pedal setting, you need to adjust your amperage right here on the foot pedal. That is a mistake that we see, or not a mistake, but that's the confusion that we see with customers when they first get the welder. They try adjusting it on the machine with using the foot pedal, and it doesn't change. You need to adjust it right on the pedal if you're using the pedal on the TIG 200 AC/DC analog machine. So same thing here. This has a range from 10 to 200, and you can adjust it from there. The other thing you will see we have on here is we have a TIG and stick function. So obviously we're showing you guys the TIG welding function today, but you can flip this down and actually hook up some stick welding lead, and you can stick weld with this with flip of a switch and a couple change of cables. And then finally we have our AC/DC switch here. So if you're welding aluminum, you're going to be flipping over to the AC side, and that's where you'll be doing your aluminum welding. But today we're going to be keeping it on the DC side, because we're just going to show you the basic rundown of using a TIG welder on mild steel. You'll also use the DC side if you're doing stainless as well. You'll keep it on that side. As far as the leads go, we have our leads are played out with nice illustrations here. We have our torch lead right here for the TIG torch. It has a gas hose that goes in. There is a little plug that is loomed in with it from the factory. And basically what this is for the finger switch. So if you're using the finger switch instead of the foot pedal is plugged in right over here, so you would swap the two of these out. They have these nice military grade connections here that you can put in. And then of course we have our ground cable here that just has a little half turn to remove. Generally you're not going to be messing with a lot of these too much unless you're switching over to the stick function. A lot of them, once they're in, are good. Just make sure that you snug up this the torch hose here, because the gas does come through there, and if you don't have that snugged up real good, you will lose some gas there and can get contamination at the torch on the workpiece. So that is the controls on the front of the machine. Any questions before I jump into showing technique.
So far, we're talking about the size of the machines, you know, why the AC/DC is a little bit bigger. It does have different electronics because it can run on both 110 or 220, whereas the digital runs on 220 only, so we need a little bit more room. Quick tech tip too, you talked about, like, you know, people getting confusion. Being I came from the tech department, one of the calls we also got a lot about, the foot pedal with that remote amperage control is really nice, because if you want to change something on the fly, you don't have to get up, walk back to your machine. But something to take note, if you're doing a lot of really thin metal, don't turn to 200 amps, because what's going to happen then is you have, you know, a certain amount of play in the foot pedal that has to vary from 10 amps to whatever you have it turned up to. So if you're working with really thick metals or really thin metals, make sure you have it turned down. That way you have more adjustment per movement of the foot pedal. So it's not trying to vary from 10 to 200. It might be varying from 10 to 50 amps. So now you have a lot more play, making it a lot easier on those thinner metals to truly vary it. You know, it is a variable foot pedal, so something to keep in mind.
That's a good one. That kind of comes by nature to me, so that's something that is good input that we get to see in the call, in the tech center rather.
Yeah, we used to get that a lot because it just is kind of confusing. You know, I think it's variable, which it is, but it just makes it so much nicer and cleaner.
Right.
Another one for you actually right now is, when do you use the finger control versus the foot pedal?
Am I on this one? This one? Wide. All right. So the finger control versus the foot pedal. I generally, with the TIG 200 analog machine, the finger switch is a on-off, which we're going to get into in a little bit. So it's strictly on or off. You can't vary the amperage. So on the TIG 200 AC/DC analog machine, I generally only use that when I need to tack weld or I'm welding something out of position. So because of it not having the variable amperage on it, basically what you set the machine at is what it's going to ramp right up to. So sometimes if you're trying to do something that's a little more intricate, that may be difficult. Now it is really nice to use on the vehicle. So we're showing you kind of best case scenario on a bench here, but if you're welding on a vehicle, definitely is nice to have that finger switch, because you can be laying inside a car, you can be welding in a cage, under a dash, and you can just have that finger switch to get, at the very least, get the parts tack welded. Now on the TIG 200 digital, I only use the finger switch, but that's because the machine has a lot more controls that you can preset, and you can actually set it to have a pulse and a ramp up amperage and a ramp down. So I can actually control how it acts, and also has a multi-process with the finger switch. So a lot more learning curve to learn how to set the machine up and everything like that, but with the analog machine you can use the finger switch and definitely get a lot of welding done on the vehicle. So that's where I use those. Long explanation, but that's it. Any other ones?
No, we're good.
Good. Okay, so one last thing I didn't talk about that I wanted, before I get away from the machine, I didn't want to jump away too quick, is the gas here. So we're using 100% argon. So you're not going to be using your bottle from your MIG. And on here, same control, or same regulator that we have on here as we've shown with some of our other machines. So we mention it all the time. Make sure when you're reading the scale that you're reading the CFH on here. So sometimes people will look at the wrong thing. I usually run on TIG a little bit higher, so I run 15 to 20 as my starting CFH and on up. So for steel, I run in the 15 to 20 range, so when you're actually welding it will drop down to like 12 to 15, and that's pretty good. Other side is obviously the amount in your bottle. We're getting pretty low there, but we should have plenty to weld today. So make sure you're checking that. If you're welding aluminum or stainless or something that requires a lot more gas, you're going to want to crank it up. Another thing is if you're welding in an odd, tight location, you may need to crank the gas up so you can get more gas coverage, especially if you're not using a gas lens, which is more into the intermediate level. So that is a quick touch on the gas regulator there. All right, so for technique and the actual TIG torch, we'll show you guys a quick breakdown of the torch. So your tungsten, there's 1/6. The most common sizes that we carry and have consumables with our machine is 1/16 and 3/32. You can get larger tungsten, but with this machine, a 3/32 is definitely adequate for 200 amps. So I have a 1/16 in here today. A lot of this is personal preference. So if you're welding a lot of like thin to medium thickness stuff, like into the 140 range, you're probably going to be okay with the 1/16. But if you are predominantly doing heavier stuff, you may want to just leave a 3/32 in there. You can change it by how you grind the tungsten. Some people like to have multiple tungstens for different type of things. It's all personal preference. But your tungsten here is going to be ground according to what you're welding. If you guys are just starting out with welding, what I usually suggest, just kind of as a rule of thumb to get you just started without getting too confused, grind it to basically almost a sharp point, and that will get you going for just a base way to grind your tungsten. If you don't have one of these fancy Eastwood tungsten grinders, insert sales pitch here. If you don't have one of these, buy one. The tungsten grinder is really great. It takes all the guesswork out of it, so you can actually put the tungsten in and you can sharpen your tungsten with the perfect degree, and you can just spin it by hand. It's really nice. Now, if you don't have one of these, you're just starting out, you can use a belt sander or a bench grinder. Just make sure when you're sanding in the direction that you're holding this in the direction that it's spinning. So you're spinning it, that your belt is spinning, and you're spinning it crossways. Will put scratches or sanding marks the opposite way, and you will get a turbulent arc coming out of that. So if not, just grab a tungsten grinder. It makes it a lot easier. You can do it right on the bench. You don't have to walk over somewhere else to grind your tungsten. So that is the tungsten. Here we have our gas nozzle. We'll thread off here. These come in different sizes. This one, for instance, is a number 6. The larger the size, the bigger the opening you will see. So this one's kind of a smaller one, but works just fine for general purpose. And you can also upgrade to like a gas lens, which will have a much larger opening. And then here we have our collet body. So this actually has the holes in it where your gas will come out and goes through the gas nozzle. These parts generally last for quite a long time. They don't really go bad. Occasionally, if you drop it, you can break the gas cup. The collet body doesn't really go bad as long as you don't abuse it or do something by accident. Then we have our actual collet here. Collet has some slits in it, and basically what that is as you tighten the back cap, it pushes it in to your collet body, which is tapered, and it will on your tungsten in there, and that's what keeps everything tight, and also is your electrical connection for creating an arc. So if these parts are not snug in there and they are loose, you can have a problem with having an issue with starting an arc. The back cap, pretty simple, just has a little O-ring on it, and basically the size of the back cap is just the size of the tungsten that's held in the back here. Some people like to have a smaller back cap. We do offer a couple different sizes that come with the machine. That's all personal preference. I run a shorter back cap because I like to keep my torch smaller for working in tight, confined areas. But if you don't want to have to cut your tungsten up, you can fit a full-size tungsten with this longer back cap right in. And just make sure you check periodically your little O-ring here. This O-ring can get ripped or damaged, and that can be a gas leak and cause mysterious contamination. So always check this O-ring. It's not anything that's specific to the Eastwood machine. We can get you one, of course, if you have an issue with one, but if you're in a bind, you can use just any O-ring that fits over there and is snug inside the torch. So that's the breakdown of our torch. I'll throw this guy back together here. Any questions while I'm throwing the torch back together, Scott?
Sure, we got a good one that's about technique. I want to know if there's different angles recommended for different materials. For example, aluminum versus steel. Do you hold the torch at a slightly different angle?
So the angle of the torch, that's more of a, I guess you should say, a personal preference thing, but generally the generic answer is no, that the angle is going to be basically the same that you're going to hold the torch out. Now the angle is more dictated by what you're welding on. Sometimes, like I've referenced, if you're welding in an odd angle or a weld joint that has a real deep V, you may need to change the angle that you're welding at. But generally, you're not going to change it from aluminum to steel. The angle is going to be basically the same. You don't want to open up, which we're going to show in a second here. You don't want to open up your angle too much because it will make your arc go across the workpiece instead of down in it, which is a common problem that we have. That's a good question. I'll definitely show the angle here in a few.
In this case, while you're talking, it worked out perfect. We have the chat going because he's actually able to say he was referring to the grind angle of the tungsten.
Oh, grind angle of tungsten.
Yeah, I misread that one.
Sorry. So the angle that you grind the tungsten, yes, that is going to vary by a few things. A, personal preference. B, the type of weld joint that you're doing. So the sharper the point that you grind on it, and the steeper of the angle, that's going to give you a really pinpoint arc. So that's good for doing detail work. If you're doing sheet metal, if you're doing, like I said, detail or edge work, you're going to do that. Now, if you're filling a big gap or a big fillet and you want to put a lot of heat into it, or if you're welding, say, a cast aluminum part or a cast iron piece, you're going to need to put a ton of heat into that to get it heated up enough to weld effectively. So you may put a more shallow angle on it, and you're also going to blunt the tip. So that's another thing you can do, is you can put a flattened tip on there. That's going to give you a wider arc that's going to heat up a larger area, and it's going to help you with filling bigger areas or a wider fillet, depending on what you're doing. But always play with it with your personal preference. I like to run mine more towards the sharp side with what I do, because I like to move the puddle around instead of having the heat spread out. So I generally keep mine on the sharp side. I'll sharpen it to a point, and then I'll just blunt the tip if I want to get a little wider of an arc coming out. But that's a really good question. Any others?
No, we're perfect.
All right, good. So now we're going to jump into technique and also cleaning the workpiece kind of all in one. So cleaning the workpiece is probably the number one most important thing. We see problems with that all the time, especially with beginners. It can even happen to pros when you start to get a little lackadaisical. You'll get into where you maybe don't clean the part as good as you should. You should try and clean the part perfectly clean, almost I sometimes say surgically clean if you can, but it needs to be clean of all greases, oils, contaminants, rust, anything. So with a MIG welder, this fresh piece of steel that we have here, that is 1/8 inch here, this would be completely okay with a MIG welder to basically just wipe it down and run with it. But with a TIG, you're going to find that the oils and contaminants that are in the surface, there is some slight corrosion that just happens from being out in the atmosphere. It will cause some corrosion that you need to get off there, and you will find light contaminants in your workpiece. So if you're working with a fresh piece of steel like this, really all you need to do is get one of these scuff pads, and you can get some low VOC pre. You want to use a low VOC pre or an acetone, because they do not have any ingredients in them that are going to burn off and cause a harmful toxin to come out. So if you're using like brake clean, I've seen, and some other more harsh chemicals like that, they will leave a film on the surface that will actually burn off when you heat it up, and it's basically going to make you suffocate. Not good. So what I'm doing is just scuffing the end here, and I'm going to show you the difference in just the color. So I'm just giving it a good scuff. This is fresh. If you're working with old metal, like if you're working on car restoration or something like that has old rusty metal, you're definitely going to want to hit it with a sander to knock all that off before you even get to the point we're at. So here's a clean rag, and even though it was a clean rag, but even though that looked like a clean piece of metal, that's all the dirt and grease that we got off of that, just from that little bit of scuffing that I did. So that's something you definitely want to make sure you do. You can really see it now that there's kind of like a hard line there. You can see just how clean that nice kind of dull brushed finish is versus this that's a little shinier, and you can see all the kind of grease and things that are better. That way. There we go. So you can even just see the fingerprints and things on it from just handling it. It may seem like it's okay to weld, but a lot of times that will cause contaminants and popping, and that is the first thing that could cause a weld failure. So that is just a quick way to clean the piece. I'm just going to give the whole thing a quick wipe down first. Clean all that off, and then we'll hit it with the Scotch-Brite. So you can use a DA sander, you can use a scuff pad. It doesn't really matter as long as you get the metal nice and clean and before you start welding. If you guys are welding a weld joint like a butt weld or a T-joint, make sure that you're actually sanding the sides, because you're going to be melting those together. So you want to make sure you clean those. That's something people often forget when they're doing it. So you can just take your scuff pad, same thing, run along the sides. All right. So we got that all cleaned off there in the area we're going to work. So this is, now we're going to talk about the mechanics of actually welding. So with your TIG torch, basically, I'm left-handed. I know it throws a lot of guys off when we weld, but basically what you're going to do is hold it. The hand that you hold the torch in is just all dependent on what's comfortable for you. I always tell beginners, weld a little bit with your torch in your dominant hand and the filler rod in your non-dominant hand, and then try switching over and see if it feels more comfortable. I've had instances where it's actually you're holding the torch in your, or holding the filler rod in your dominant hand is better, because some people feel more comfortable with feeding the filler rod with their dominant hand. But I hold the torch in my left hand, that's my dominant hand, and I hold the filler rod in the other hand. So what you want to do is basically imagine the torch right here, almost like you're writing with a pencil. So like with a filler rod, imagine holding it like that. You're holding your torch kind of the same way. So I sometimes hold the switch when I'm welding. We're not on panel control, so you can hold it down. But I hold it like that. Try and keep your hand, don't go any further up than this. This area that necks down here is what gets really hot. So I've seen beginners, they like to try and be more stable by holding it up here. It gets hot really fast, and the more your hand gets hot, the less you're going to be focusing on your weld technique and more on how hot your hand's feeling. So hold it down in here, no further up than where the knurled area stops, and that will be pretty safe. So hold it like that. When you go down on your workpiece, a good way to practice is to go down and keep it, straight up and down like that, and then turn it back. So I'm left-handed, I'm turning it to the left, turning the back cap back and the nozzle in towards the way we're traveling. About 10 to 15 degrees is a good starting point. So basically what you're doing is opening it up enough that you can actually see the puddle and see the end of your tungsten. If you were straight up and down, which is totally okay, you just can't see your tungsten and get it in there and you'll end up dipping it. So if you turn it back 10, 15 degrees, that will be enough that you can actually see what's going on. Dip your filler rod as you move across. But the more you open up or turn it down, lay the back cap back, you're going to find that it's going to put more heat out into the center of the panel, and you're going to start having your puddle get really large. It's going to start heating it up. If you're welding thinner gauge, blowing holes and everything. So try and keep your arc as focused as you can. Like I said, 10 to 15 degrees. Tap is a good way to go. So start straight up and down. Do your 10, 15 degrees like that, and you're good to go. You can go a tiny bit more than that if you need to, but I wouldn't go much more than like 20. So that's a good how to hold your hands. You're going to travel from, if you're right-handed, from right to left. If you're left-handed, from left to right, across the panel. And you're going to be dipping your filler rod as you go. When you guys are learning or just beginning, I definitely suggest to work on a workbench. So keep the heel of your hand on the workbench or on a straight edge. So on our workbench here, I've always sanded the edge to keep it free of any type of burrs so that we can use that on the edge and you can slide your hand across. What that's going to do is keep your hand steady, and it just takes one more thing that could go wrong out of the equation there. So if you keep your heel of your hand on the workbench, that will keep you nice and steady, and just keep light pressure on it, and you can just drag your hand right across, and you don't have to worry about trying to hold it as well as do everything at one time. So that's how to hold the torch. Tungsten. So tungsten feeding is, this is a personal preference how you hold it, but basically the way I like to do it is I pinch with my first finger here and my middle finger, and then I feed it with my thumb. So I'll kind of leave it sit on my middle finger there, and I'll push with my thumb as I go, and that's how I feed. And I'm just using my pointer finger there as kind of just to steady it. But that's how you can feed filler rod. That's really important to practice when you guys are just learning. Make sure you are sitting there practicing feeding your filler rod, because if you can't feed filler rod smoothly, doesn't matter how good your torch hand is, you're going to have problems with welding. So do not hold the filler rod out like this and let it hang out in the open like that. What you're going to find is the filler rod's going to be hard to control, and you're going to have an issue with dipping your filler rod, and it's hard to kind of see what you're doing. So choke up on it, leave maybe 10, 12 inches hanging out at most, and then you can just feed as you go. Some guys like to hold it even closer than that, but anywhere in that 6 to 12 inches is totally okay. It's just that you want to keep it nice and steady. So just practice feeding your filler rod as you're working. Any questions before I jump into doing some welds?
Sure, we got a good one for you that they wanted to know about whip management when welding and how to control the weight while welding to avoid getting it tangled or anything like that.
So the torch, when you're trying to weld, again, this is a personal preference thing. The way that I do a lot of times is I throw the torch over my shoulder like that, and I'll put the most of the weight will be over my shoulder. I just have a little bit right there kind of under my arm, and that will give me enough slack that I can move around anywhere I want, and I have all the weight pretty much off of my hand. So that's a good way to do it. Some people will prefer to lay it in their lap. So sometimes when I'm welding in a vehicle or on a vehicle, I don't want to get tangled up, so I'll actually put the weight of it in my lap. Same thing, leave a little bit of slack under your arm, and you can work like that. So definitely keeping the weight off of your hand is good. Also, when you're welding, try not to put all of your body weight on your hand because you're going to have trouble traveling across the panel. Try and keep a really light weight on your hand. Be very conscious of that when you're setting up the weld, that you're not leaning down on your hand, because then you're not going to be able to move. You want to keep light pressure and just be able to move nice and steady as you go. Good one.
No, we're good. Now we're back in business to welding.
All right, so we're going to turn the machine on, and we're going to do some puddle stuff. Sounds fun. All right, flip the machine on. Make sure that your ground, you have a good clean ground connection. One thing safety-wise that's a little more dangerous than MIG welding is that this tungsten here is actually jumping the arc from the tungsten to the panel, and with this machine being a high frequency start, you're going to be just above the panel and it's going to jump an arc. If you have a poor ground and your hand or your arm has any bare metal and it's closer to the ground, it's going to jump the ground over to you and you can actually zap yourself or electrocute yourself. So not a big deal if you're on low amperage, it's just going to be a little tingle, but if you're doing on higher amperage, it can actually be really dangerous. So make sure you have a good clean ground. We have a nice clean metal welding table that we use here, so I can ground to the bench and I can ground, it'll ground through the table to the workpiece with no problem at all. If you're welding on a vehicle, try and get your ground as close as you can to the area you're welding and make sure that area is sanded and cleaned very well so you get a nice clean ground connection. So I'm going to throw my gloves on and my helmet, and Joe's going to do his underhood magic, and I'm going to talk you guys through the welding as we go and making a puddle here.
Underhood right away?
Yeah, let's do it. That's they want to show the people what they want to see, sucker. All right. We'll do a bunch of underhood, and hopefully I'll get some questions maybe going here as well. So I'm going to pull my tungsten out a little further so you can see it a little easier. So I get set up with my 15 degrees or so there.
Give it a whirl.
All right, so I'm using the pedal here so I can go, I have it at 140 amps max, so I can go from like 15 amps or so on all the way up. So usually what I do is I start my puddle at a low amperage like that, and then I slowly start pushing the pedal down. As you see a puddle start, you can see that little puddle in the center kind of start. I'll start giving it more amperage. Once it opens up and you see the puddle, it's pretty decent size there, and add your filler rod. And you add your filler rod right to the front of the puddle, not the center. Like that, just a little dab. It'll kind of suck the filler rod off. You don't need to shove it in there necessarily when you're just first learning on flat like this. You know, just dip right to the front like that. And if you see that the heat's getting out of control, you can actually back off the pedal a little bit. You'll see the arc kind of get not as bright. You can get yourself back under control if you're getting a little hot, and kind of establish or get yourself more comfortable. And then if you need more heat, it's not melting how you want, we can crank it up like that and we can move quicker. And I'm just dabbing right in the front of the puddle like that, not shoving it in there, and keeping my height pretty consistent as I'm dabbing.
And then when you're done, put a dab in, slowly back off the pedal like this. Slowly, slowly. And when you let off the pedal, keep the torch over the puddle.
And the filler or the post flow will flow out. And once you hear the post flow stop and the solenoid click off on the machine, then you're good to pull your hand away. So you can actually read your weld here where I started to slow down right in here, and we didn't have enough amperage. We weren't able to deposit enough filler material in there. So that's where you can actually read your panel and look at what you were doing. And then here I heated up and I started dabbing quicker and moving faster as I was going. So as a general rule of thumb, as you get better, you want to be in and out as quick as you can so you can put a bunch of heat in and dab and move across the panel quickly. That's going to help you. And you want to get in and out as much as you can and weld kind of like as hot as you can without actually burning through. You want to put the heat in there, deposit the filler rod, blend everything together. So hotter is always better if you have the technique down to actually move quick enough to do that. Any questions before we'll do another one?
No, we're good to keep cruising along.
All right. So what I'm going to do in the next one is I'm going to weld, and I'm going to open up and turn my torch angle so that it opens up and is further than the 10 to 15 degrees, and you guys can actually see what happens with the weld puddle. So we'll do this one. If you guys have any other extra questions, we're getting towards the end of our crash course here. So make sure you drop some questions in with Scott, and he can either answer them himself or he'll save some till the end that we can also answer. All right.
Ready to go?
Yes, sir.
Let's do this.
All right, so again, we're going to start low amperage just to get a puddle started. I call it my flashlight just to kind of see where you're at, and you just get a puddle barely dancing around. And then you can push the pedal down further, get a puddle started. So I'm at my 10, 15 degrees here. And dabbing as I go, just right at the front of that puddle. Now, I'm way past 15, and you can see what's happening here. It's melting my filler rod before I'm even ready. See how it's globbing it? That's too far, and it's actually heating a huge area around the panel. So now we're going to turn it back to closer to where we want it. But now we have a ton of heat into that panel. So I'm going to let off. Hold your torch there.
Let your post flow go. So again, we can read our puddle here. So you can see in the beginning, I have a nice flat weld going along. And you can see right here where it opened up. You can see that the puddle got larger, but also the heat, it moved itself way, way out. And we were much tighter in here. Our heat affected zone got much larger as we were going in this area here. And like I said, we were melting rod before we were actually melting the parent material, so we're not really depositing the material into the base material, so that if you're trying to weld a weld joint, you may not be getting a 100% fusion like you would want. So make sure you're keeping yourself under control with the angle that you're going with your torch and also your height, because both of those can cause the panel to heat up like that. So that's a quick demonstration of one of the most common things I see when people are learning how to TIG weld. They either lift their torch up or they lay their torch back, and it starts to make the heat get out of control, and then the panel gets really hot, and they're trying to add filler rod, it just turns into a mess. So keep that in the back of your head while you're welding to keep your 10 to 15 degrees in that range. Keep it right around there as you're welding, and you'll be one step closer to stacking dimes. Any questions?
Sure do. So while you're talking about the filler rod, want to know if there's a general rule of thumb when picking out the size of your filler rod.
So general rule of thumb, if you're welding, you want to try, when you're welding on, like I should say, thinner stuff, sheet metal up through that kind of material, you want to try and keep the filler rod about the same as the parent metal. So if you're looking to do automotive sheet metal work, If you're welding on like 20 gauge steel, you want to keep your filler rod right around 030, 035 because it's going to be really close to the parent material because you want it to melt at the same time. When you get up into your thicker materials, that's where it becomes sort of a personal preference, but with the thicker materials as you go up to like 1/8 inch and beyond 1/8 inch, you're going to go from like the 1/16. Once you get up beyond that and into 1/4 inch, 3/16, 1/4 inch and up, you're going to probably jump up to your 3/16 filler rod, 3/32 filler rod, and that's where you're going to use the thicker rod. Now, they also have 1/8 inch filler rod. It's even larger that you can use when you get into some really high amperage welding and filling big gaps. That's where you may use it. For most automotive work where you have a good clean weld joint, you can use either 1/16 or 3/32. Again, I go back to kind of the personal preference. You can use either rod. If you're using 1/16 and it's on higher amperage, you're going to have to just move and fill the rod quicker. So you're going to go through rod a lot faster, where the 3/32 you're going to be able to add just little dabs at a time. So some people like to have the thinner rod that they can add the filler rod as they need more quickly, whereas other people like the 3/32. I judge it on that. So if you're going like into 3/16 and up, a lot of times you can probably jump to the 3/32 and you'll be safe. Anything 1/8 inch and down, I usually use 1/16, and then when we get into sheet metal, that's where I start using the really thin stuff like 035, 030 in that range because we're doing sheet metal. Hopefully that answers that. Any other ones?
Nope, that was perfect.
Cool. Well, thank you guys. We appreciate you guys watching. Thank you again for purchasing an Eastwood TIG welder. This is just a quick kind of jump start on TIG welding. We have a ton of videos on our YouTube channel. I've done a few of these broadcasts where we've gone way more in depth on different things. So if you guys want to learn a lot more and you want to sit and watch some longer recorded versions, we have those on our YouTube, Eastwood Company. You can go right on there, type in TIG welding, and you will see a ton of great videos on all the different aspects of TIG welding that if you watch those and kind of practice, you will be one step closer to being a proficient TIG welder. That's all I have for this one. I appreciate you guys watching as always, and we'll catch you guys later. See ya.